So you've got your choice, Thevenin voltage or Thevenin impedance. Okay, so when you draw for your Thevenin impedance, you're going to draw the same circuit, but you short out your supply, don't you? And the pen's going to run out just at exactly this point.
I have the same 3 times with this week.
So you short out your supply. You remove your load, leave those terminals open. Keep your component values the same. Just that one off of there. And what you're really doing is you're kind of pretending that your supply was over here, and it's usually shown to you in books as if you're looking in from that direction. So you're redoing your circuit as if your supply is on this side and you're working out what the total impedance is over here. So if you were going to do that, then looking at this circuit, you would see that this 600 and this minus J200 are in parallel. That's your parallel section. And then all of that is in series with that. So you're going to do your R1 in parallel with your capacitor. Get your answer for that. And then you're going to do that, we'll call it ZP, plus that value for that inductor. And that would get you the 2. Now remember that when you're doing these, for example, so when you're doing R1 in parallel with C, you're going to use complex numbers. So on the top you do the product over the sum, so you multiply over what you add, and when you multiply you want it to be in polar form. And that is those 2 in polar form. So 600 at an angle of 0 for the resistor, and 200 at an angle of minus 90 for the capacitor. And then in rectangular form, a resistor is real, as in 600 plus J0, and a capacitor is 0 minus J200, as is shown there. So I'll leave you to work through that, and then you can get your final answer. Okay, so when you've worked that out, you've got your 189.74 at an angle of minus 71.57, or your rounding might be slightly different. So you're going to take that, and that becomes your value for your ZP there, doesn't it? So now you're going to add that 189.74 at an angle of minus 71.57, and you're going to add on this value for this inductor here. So that is a J150. Now because you want to add this value to this value, you have to convert this value here into rectangular form. So when you add and subtract, you add and subtract in rectangular, and when you multiply and divide, you divide in polar. That's the next thing I'd like you to work out. Is that converted into rectangular form with that added onto it? So when you've worked this out and you've got this polar answer here, sorry, this rectangular answer here from adding these two, when you're thinking about moving on, I think it's a good idea to have this in polar form as well. So you've got both forms of it. So if you could convert that as well. We might not use it going forward, but at least we've got the choice. Have you already worked it out, Lee? Mm-hmm. What do you think it is?
Yeah, 67.08 at an angle of minus 26.58.
And do you agree with that? Okay. So that's you now got your Z Thevenin. So you've got your Thevenin impedance. So that's your impedance looking in this way from the circuit, with your load removed, and pretending your supply's over here, which makes your capacitor and your resistor in parallel, and then your inductor in series with that. So this part of the calculations for your capacitor and your resistor in parallel, and then this part is for that parallel part with the inductor added on. So that's you got your Z Thevenin. So your other task is to do your V Thevenin. So your V Thevenin, if you remember, you're going to redraw your circuit with your load removed and work out what the voltage is across the terminals where the component was removed. So that's your next step. I'm going to draw mine a little bit smaller just so I can fit everything in that I want to fit in. I'll just leave my values out just so that it's a wee bit clearer. And what I'm trying to measure is as if I'd taken a voltmeter and put it across here.
How did you get the 180 like with so much more?
Well, so on the one end of this is connected when you remove this load resistor, so no current will flow. So now essentially you've got your supply there with a resistor and a capacitor, and you want to know the voltage across this part. When you disregard that, it's really the voltage across that capacitor. So how would you go to work out what the voltage across that capacitor would be in that circuit? Looking at this circuit, how do the resistor and the capacitor connect? Do they?
Series.
They're in series, so there's only one current path now, isn't there, when you disregard that? So if they connect in series, and you want to get the voltage across one of them, you could just use a voltage divider, couldn't you? So if you want the voltage, and it'll be the voltage across that capacitor if you like, so you do the voltage across the capacitor. The supply voltage is the voltage you're going to divide. Then the capacitor is the thing on the top, so that will be the minus J200 if you like, over the two added together. So 600 minus J200. So again, if you can work that out, and then let me know when you have your final answer. Okay, so if we went through all the steps, you should get to this. The next step is to get these two values that you've got for Z Thevenin and V Thevenin into a Thevenin equivalent circuit. Do you remember what a Thevenin equivalent circuit would look like? Ish. I'll leave that underneath just now. Thevenin equivalent circuit is going to be so in a Thevenin equivalent circuit, you're going to have your Z Thevenin in series with your V Thevenin. You're going to kind of effectively have the 2 points where you removed the load, and you're going to reattach the load at that point there. So your Z Thevenin, that's that one there, that's 67.08, an angle of minus 26.58 ohms. And your V Thevenin, which I've missed the volts for there, is 3.84 minus 71.57. And your RL, taken from that circuit as well, is 100 ohms. So on that Thevenin equivalent circuit, what do you think the best way would be to find the voltage across the load? What are your options? So your Z Thevenin and your RL, they're in series, so because they're in series you can use a voltage divider. The voltage you're going to divide is your V Thevenin. The voltage you're interested in is the voltage across that RL, so RL goes in the top. And then on the bottom you're going to have the two impedances in the string, if you like. So Z Thevenin plus your RL. Now because you're multiplying there, you want these ones to be in polar form and you want these ones to be in rectangular form. So your V Thevenin is your 3.84 at an angle of minus 71.57. Your RL, that 100, when you put that into polar form, it's 100 at an angle of 0. Your Z Thevenin, you'll have that hopefully in rectangular form, you do. So it's 59.99 minus J 30.01. And then your RL, when you put that resistance into rectangular form, it becomes 100 plus J0. So now go through the steps to reduce that and get the value of the voltage across your load. What answer did you get?
2.36 at an angle of negative 82.19.
I've got that as well.
Okay, so we've got a few confirmers. So if you wanted to get the current through the load, what would you then do?
The current.
What would your formula be for it, do you think?
V over R.
Which V?
R.
What you just got.
The one you just got, the VL?
No, is it not
The
the
VVL.
3.8?
2.36.
Well, you can either do VL over RL, or because it's a series circuit, you could do V Thevenin over ZT if you like. Both should give you the same answer. So whether you do it that way or that way, you should get the same answer. In fact, we'll maybe get, could the back row do it that way, and the front row do it that way?
Right.
And then we'll see if we get the same answer.
IO, VO.
So this is for the people in the back row. This is for the people in the front row. Yeah, so when we've done this would have given you something that was overall a minus J, which would get you a minus angle. So when you do your 0 minus that negative angle, that will get you a positive angle, which will bring this minus 71 up closer to 0. So minus 60.95 makes more sense. So this I would think now is right. So hopefully the front row have also got this. What have you got, Lee?
0.06. Where is 0.02? I got 23.59 times 10 to the minus 3.
Right, so that's the same, 23.59 times 10 to the minus 3. So you've got, so that's 0.02359. What angle did you get?
I got 82, negative 82.19.
Your angle's away. Your Z total, that will be, say, 160
I've got that.
minus J30. And that's the same as
Wait, no, I'm talking. Sounds like I'm doing
yeah, minus 60.95. You must have done some weird angles. So when you do that, minus 71.57 minus minus, that becomes a plus.
Yeah, that's what I done, that's one of the first bit. That's
Yeah.
what I got 81.
So that was the error that had happened here.
Yeah.
So when you do minus 71.57 plus 10.62, it brings you up closer to 0, doesn't it?
Yeah.
Gets you minus 60.95. That's amps. That's amps. Done?